Going to be drawing Lewis structures today. So we got a few rules to think about, and I'm just going to highlight a few words while you're reading. Not that they're already underlined. Valence electrons. Count. Choose least electron. Central atom. Or whatever. The line. Whatever. Remaining. Octet. Okay. So we'll get to each of those rules for these molecules that I've drawn up here. We got covalent bonds, they count toward each other's octets. And we've got an octet rule. So 8 is the maximum number of valence electrons any atom can have. And so nonmetals, when they bond, they stop bonding when they have 8 valence electrons. There are exceptions. You'll see those later. Let's do HCO. So HCO, we're going to do the first thing. Count the valence electrons. So valence electrons, we have your periodic table. Group 1 has 1, group 2 has 2, 13, 3, 4, 5, 6, 7, 8, except for helium. Helium only has 2. The other noble gases don't bond until we get to some of the exceptions with xenon, so we're not really using those very often. But just count your valence electrons with a periodic table. So we have 2 plus 4 plus 6 equals 12. We have 12 electrons to make a structure with those 4 atoms. That's first. Least electronegative atom as the central atom. That is the atom that is farthest from fluorine, which is the most electronegative. The farther away you get, the lower its electronegativity. So we have a choice between oxygen and carbon and hydrogen. We can't pick hydrogen. Hydrogen only forms one bond. It can't be a central atom. Central atom must be carbon. Okay, so that's our skeleton structure. And we did that. Add remaining valence electrons until all atoms have a full octet. So we've used 2, 4, 6 electrons. We have 6 electrons left. I'm going to add them to the oxygen first. 2, 4, 6. I've added 6. Until everything has a full octet. So hydrogen doesn't need a full octet. Hydrogen only needs a duet, right? 2 electrons. So once hydrogen has a bond, it's done. The thing we're worried about is carbon and oxygen. I'm going to draw a circle around the electrons that count toward oxygen's octet. Right. Any electron in that circle counts toward oxygen's octet. That's 2, 4, 6, 8. All right, so oxygen has an octet. How about carbon? All those electrons count toward carbon's octet. 2, 4, 6. We do not have enough. This can't be the structure for carbon. And so what do? Well, there's if too many, if too few electrons. We don't have enough to give all octets, so we need to make 1 or more double or triple bonds. So what we do is this. We take these 2 electrons and add them there. It's a little close to those. I like to spread things. So we have that. We've still used 2, 4, 6, 8, 10, 12 electrons, but we now have 2, 4, 6, 8 for carbon and 2, 4, 6, 8 for oxygen, so the octets are filled. When you're drawing Lewis structures, please use a pencil. That way you can erase the electrons and put them back. Nitrogen. So we have 2 atoms. There's not a central atom if you only have 2 atoms. You look at the periodic table, we've got 10 electrons. Bond them. All right, put them together. Now we're going to add electrons until we've got the octet. So we've got 8. We've used 2. We've got 8 electrons left. 2, 4, 6, 8. I'm just kind of spreading them out. And we see that that's not enough. We don't have octets, right? If I drew this circle here, Right? If I do that circle, there's only 6 electrons in that nitrogen's vicinity, and there's only 6 electrons in that nitrogen's vicinity. So if we have too few electrons, we need to make 1 or more double bonds. So we take those electrons and we put them here. 2, 4, 6. We still don't have enough for this guy. So we take 2 more electrons and share. 2, 4, 6, 8 for the nitrogen on the left, and 2, 4, 6, 8 for the nitrogen on the right. That is your Lewis structure for nitrogen gas, without the circles, right? That's your Lewis structure. All right. CO2. CO2, we got 4 electrons for carbon plus 12 for 2 oxygens is 16 electrons. So,
Office Madam, please come to the front desk. Office Madam, please come to the front desk right away.
there's our skeleton structure. We have carbon as the central atom. It's the least electronegative. Now we've used 4 electrons. We have another 12. So I'm going to go ahead and add them. 2, 4, 6, 8, 10, 12. So count them. Make sure that you do see I have a total of 16 electrons on the board. Octet's good for oxygen and the other oxygen, but carbon only has 4 electrons. So we're going to need to start sharing some electrons. So that is your structure for carbon dioxide. CCl4. We've got 4 valence electrons for carbon. Chlorine has 7 times 4 is 28 equals 32 electrons. So we want to make this molecule, that's what we've got. So we draw carbon as the central atom. That's our skeleton structure, and we've used 2, 4, 6, 8 electrons, meaning we have 24 electrons left. 24 electrons, if I spread them out here, so 4 atoms of chlorine, it would be 6 each. We got that, and we have octets for everything. Carbon has 2, 4, 6, 8. Chlorines all have 2, 4, 6, 8, so we're good. SO2. We have 6 for sulfur plus 12 for 2 oxygens, so we've got 18 electrons. And we make our sulfur in the center. That uses 2, 4, that means we have 14 electrons left. So I'm going to start adding them to, I add them to the outside atoms first, just to fill those octets. 2. Right, we've added 12, so we have 2 more. I'm going to put those on the central atom. But if you notice, we don't have the octet for sulfur yet, so one of these oxygens, doesn't matter which, is going to need to share. That's SO2. CO3 2 minus. We've got a charge here. So if you have a negative charge, that means you have an extra 2 electrons. So we've got 4 electrons for carbon. 3 times 6 is 18, plus 2 is 24 electrons. We've got 24 electrons to make a carbonate ion. Anytime you see this charge, when you draw your Lewis structure, make sure you have brackets around it. So we show the charge there, we show that an extra 2 electrons than people would normally expect are there. So we've used 2, 4, 6 electrons. That leaves us with 18. 18 spread to these 3 would be 6 each, so I put that. But that doesn't give us an octet for carbon. Just make sure you count and you see there are 24 here, right? 8, 8, 8. So the octets are good for oxygen. Carbon does not have an octet. So one of these atoms is going to need to share a pair of electrons, and that'll work. So now oxygen has an octet, carbon has an octet, 2, 4, 6, 8 electrons for carbon, and the bottom oxygens are fine too. That's carbonate. It doesn't matter where you put the double bond. In fact, that leads us to another term, which is resonance and resonance structures. This polyatomic ion will have 3 total, 2 other resonance structures. So, they look like this. So these 3 Lewis structures are equivalent, right? We have a carbon in the center with the, you see it, right? 1 oxygen double bonded, 2 oxygen single bonded. So these are all the same, and they're called resonance structures. So if you can draw something like this, where all you're doing is you're moving some electrons down and you're just moving the electrons. You're not changing the atoms the way that atoms are bonded, or which atoms are bonded to which. We're not changing that. We're only changing where more electrons are. Then we have something that is called a resonance structure.